Have you ever wondered why planes don't fly over the Pacific Ocean? An intriguing question, isn't it? Despite being the largest ocean on Earth, the Pacific is often avoided by flight paths. This might seem counterintuitive, especially when you consider that the shortest distance between 2 points is a straight line. So why wouldn't planes just fly straight across this vast expanse of water? What's stopping them from taking this seemingly obvious route? Stick around to discover the reasons behind this aviation mystery. To begin with, planes do fly over the Pacific Ocean, but the routes they take may not be what you'd expect. Now, you might be wondering, why the unexpected routes? Well, it all boils down to the concept of the Great Circle Route. Let's dive into what that means. If you were to slice the Earth into 2 equal halves, the intersection line you'd see is what we call a great circle. This circle provides the shortest distance between any 2 points on the globe. Shortest distance? You might think. But I've seen flight paths on maps and they're anything but straight. Well, you're not wrong, but remember, maps are flat and the Earth, as we know, is not. Our planet is a sphere, a 3-dimensional object. When we try to project a 3-dimensional object onto a 2-dimensional surface, like a map, things can get a little distorted. Bear with me here. Imagine stretching a rubber band from New York to Tokyo. If you could see this rubber band from space, it would make a straight line, right? But if you took that same rubber band and laid it out on a flat map, it would appear to curve. That's precisely what happens with the Great Circle Route. So, when you see a flight path curving up towards the Arctic or down towards the equator, it's not because the planes are avoiding the Pacific. In reality, they're flying the shortest possible path, the Great Circle Route, over parts of the Pacific. But why do planes follow this route? It's simple, really. It saves fuel. And in the aviation world, saving fuel means saving money. So airlines aim to use the Great Circle Route as much as possible. But wait, you might say, why don't they fly directly over the middle of the Pacific? Well, that's a great question, and it brings us to our next point. Another reason planes don't fly straight across the Pacific is due to fuel efficiency and wind patterns. You see, the sky isn't just a vast expanse of nothingness. It's a dynamic, ever-changing environment that's constantly influenced by the Earth's rotation and temperature differences. This results in wind patterns, which can significantly impact a plane's fuel efficiency. Now, let's talk about jet streams. These are narrow bands of strong wind in the upper levels of the atmosphere, and they're a big deal in aviation. Why? Well, imagine you're on a bicycle pedaling against a strong headwind. It's tough, right? You'd have to work much harder and expend more energy to reach your destination. Similarly, when an aircraft flies against a jet stream, it burns more fuel. On the other hand, if you're cycling with the wind at your back, you'd find the ride much easier. You'd use less energy and reach your destination quicker. The same principle applies to planes. Flying with the jet stream or tailwind can significantly improve a plane's fuel efficiency. But here's the catch. The Pacific Ocean's prevalent wind patterns often don't align with common flight paths. The jet streams over the Pacific are predominantly eastward due to the rotation of the Earth. So, for a plane flying from the United States to Asia, which is a westward route, the jet streams wouldn't provide a tailwind but rather a headwind, making the flight less fuel efficient. And let's not forget, fuel efficiency isn't just about saving money. It's also a matter of environmental responsibility. The more fuel a plane burns, the more carbon dioxide it emits, contributing to climate change. So, wind patterns and fuel efficiency contribute to why planes don't fly straight across the Pacific. But there's one more important factor to consider. The final major reason why planes don't fly straight across the Pacific Ocean is for safety. You see, when it comes to long-haul flights, there's a critical regulation known as ETOPS, which stands for Extended Range Twin-Engine Operational Performance Standards. It's a safety rule that's been around since the 1980s, and it's all about making sure that twin-engine planes are never too far from an airport, just in case one of the engines fails. Now, you might be wondering, why does it matter if a plane has 2 engines or 4? Well, the answer is simple. If a plane with 4 engines loses 1, it still has 3 left. But if a twin-engine plane loses 1, it's left with just a single engine. And that can be a much more precarious situation. Therefore, the ETOPS regulation stipulates that twin-engine planes must always be within a certain flying distance of an airport where they could land if necessary. So, how does this relate to our topic at hand? Well, the Pacific Ocean is vast, really vast. It's the largest and deepest of Earth's oceanic divisions, covering more than 63 million square miles. That's more than twice the size of the world's second-largest ocean, the Atlantic. And with such a vast expanse of water, there are far fewer suitable airports where a plane could make an emergency landing. Imagine you're on a flight, cruising over the Pacific, and one of the engines fails. If the plane was flying straight across the ocean, it might be thousands of miles from the nearest airport. That's a risk airlines just aren't willing to take. So instead, they plot a flight path that keeps them within range of airports along the coastlines or on islands scattered across the ocean. In conclusion, the Pacific Ocean's immensity, combined with the safety requirements of the ETOPS regulation, means that straight-line flights across the Pacific are not just impractical, they're downright dangerous. Safety regulations like ETOPS are crucial in determining flight paths over the Pacific. To recap, planes do fly over the Pacific Ocean, but not in the way you might think. There's a lot more going on behind the scenes of your flight path than meets the eye. First, we discussed the Great Circle Route. This isn't your typical straight line on a map. It's the shortest path between 2 points on a sphere, like our Earth. So, when you're jetting across the globe, your plane is following this curved route to get you to your destination in the quickest possible time. Next, we touched on fuel efficiency and wind patterns. Planes don't just soar through the sky aimlessly. Pilots and flight planners consider the prevailing winds and jet streams to maximize fuel efficiency. By riding these air currents, planes can save on fuel and reduce emissions, which is a win-win for both airlines and the environment. Finally, we delved into safety precautions. The Pacific Ocean is vast, and emergency landing spots are few and far between. Flight paths are carefully plotted to stay within a certain distance of land and potential airports just in case of an emergency. This means planes often skirt the edges of the Pacific rather than crossing it directly. So next time you're on a flight and notice the path seems to avoid the Pacific, you'll know exactly why. Understanding why planes don't fly straight over the Pacific Ocean gives us insight into the complex world of aviation. This complexity is not just about the mechanics of how an airplane works, but about the intricate web of factors that go into planning a single flight. Each flight we take is the result of exhaustive calculations, thoughtful planning, and strategic considerations. It's about understanding the Earth's geometry, the wind patterns, the fuel efficiency, and above all, the safety of every single passenger on board. Imagine the countless flight paths crisscrossing the globe, each one plotted with the precision of a master chess player making their next move. The Great Circle Route, for instance, isn't just a quirky geographical fact, but an essential tool in the aviation industry. It's a perfect example of how pilots and flight planners use the Earth's own curvature to their advantage to save on fuel and time. And it's not just the Earth's shape. Wind patterns play a crucial role too. The jet streams, those fast-flowing, narrow air currents in the atmosphere, are like invisible highways in the sky. Pilots ride these highways, saving fuel and reducing the flight time, a beautiful dance between nature and technology. But above all, it's about safety. The decision to avoid flying directly over the vast expanse of the Pacific Ocean is a testament to the aviation industry's commitment to the safety of its passengers. It's about being within reach of an airport at all times, should there be an emergency. So, the next time you're on a flight, look out the window and marvel at the invisible lines of flight paths, the unseen currents of wind, and the delicate balance of factors that make your journey possible. Keep wondering, keep asking questions, and remember, there's always more than meets the eye.